So here I want to do a problem from our text, number 15 from chapter 12. And in this problem, basically we're asked to calculate the total heat in joules needed to convert. And here we have 22 grams of ice, and it is at minus 6 degrees Celsius. And we're going to convert this to water in the liquid form at 0.5 degrees Celsius. So one way to think about this would be to draw a little diagram like we've talked about in our text. And so if you've got your temperature here, so we want to know how much energy is going to be needed to heat this ice up. Now, we're going to start off we're at 6 degrees, -6 here. And so if we come over in our chart, we're going to basically be, we'd be starting off here. And we're going to increase in temperature till we get to 0 degrees. And then at 0 degrees, so if this is heat, so this would be heat in joules. So we're going to add heat until we get up to here. Then our temperature at 0, then will stay the same. And so here in this part, we are in the solid state. Here we're going solid to liquid transition. Now then once we melt all of that 22 grams of ice, then basically we're going to go up another ½ degree, which I'm just going to denote here as 0.5. And then basically we need to calculate this energy, the total energy to go from here, starting out here, going all the way to here. Now, part of the reason I've drawn this out is so you can see that it's in 3 stages. So here we're going to have Q1, here we'll have Q2, and then here we'll have a little bit of energy, which we're going to call Q3. Okay, so that's just kind of a diagram of what we're doing in this problem. Now, so to work this problem out, we're going to, first, let's just go ahead and calculate the number of moles. Now, we don't need it in the first part because our first heat capacity is given in joules per degree Celsius per gram. So that's a specific heat capacity. So Q1 and Q3 we can calculate with the grams, but for the Q2 we're going to need the number of moles. So let's start off by calculating that. We've got 22 grams of H2O, and we're going to calculate moles by taking our molar mass, which is 1 mole is equivalent to 18.02 grams of H2O. So our grams are going to cancel out. We would be left with 1.221 moles of H2O. Now, then we are going, so basically that's our moles, which we'll use for step 2. Now, Q1, we're going to calculate, we're going to use the heat capacity. So remember, we're going to have just the general form of heat capacity times the mass times the change in temperature. And our change in temperature is in degrees Celsius. But basically, remember that when you talk about delta T, 1 delta T of Celsius is the same as 1 delta T of Kelvin. I had a couple people asking me about that relative to the quiz. So when you talk about delta T, remember you can't calculate delta T in Celsius and then convert it to Kelvin. You can't do that. You'd have to calculate the kelvins first and then calculate the delta, but then the delta for Celsius and Kelvin will be the same. If you have questions about that, feel free to ask me for clarification. But let's go ahead and do this part. We've got 2.09 joules per degree Celsius per gram. We're going to multiply times our 22 grams. So grams are going to cancel here. And then we're going to have our change in temperature, which is 6 degrees Celsius. And 6 degrees Celsius will cancel against this degree Celsius. And so if we carry out that calculation, we're going to get 275.88 joules. Then for our Q3, we're going to get, we're going to do our number of moles times our delta H of fusion or melting. So, right, fusion and melting. Fusion is freezing and melting would be the opposite, but we'd use this term. Then we are going to use our 1.221 moles times our 6.02 kilojoules per mole. And then we wind up with 7.350 kilojoules. Oops, I'm sorry here. I meant to put Q2. And now we're going to calculate our Q3, which is equal to our heat capacity in the liquid state, which is 4.21 joules per degree Celsius per gram, another specific heat capacity. So here we use 22 grams, and we use our half degree Celsius, and we would get 46.31 joules. Now, one of the things before we would add these up, we would have to convert this to either kilojoule, we'd have to convert this to joules so that we could add up the joules. And that's very easy to do. We'll just multiply this times 1,000 joules is equal to 1 kilojoule. And so what we get is 7,350 kilojoules. Now, if we get to get our Q total, we're then going to add these all together to 275.88 plus 7,350 plus 46.31. That will give us 7,672 and 0.19. And that would be in joules. And so basically our answer here, if we round this off, we did have 22, let's see here, we had 22.00 grams, but we have 3 degrees on our temperature. So we'll round this off to 3 significant figures. We've got 7.67, or I'm sorry, 7,670 joules. And that would also be equal to 7.67 times 10 to the 3 joules. Or we could have 7.67 kilojoules. Okay.